Hi, I'm Randall Heyman, a mathematics academic. Welcome to my Corona Help playlists where I do quick turnaround videos to help educators and their students. If you'd like me to make a video for you, be it at primary school, secondary school or university level, then comment me below any of my videos or drop me an email. So I said in the last video that I would do a problem that you might sort of see in using this very pretty theorem that I went through last video, which showed that there's this equivalence between between continuity when we do the what's called the some people say the dreaded delta epsilon definition of continuity with the definition that involves sequences with, and importantly for us, one that involves open sets, which is what we've been talking about in the last 3 videos. Okay, so let's talk about a problem that I want to do. Actually, in the book by Morgan, he has this problem. Use definition 2. So he's numbered differently. So I'll quote him correctly, I think. Use definition 3 to prove that the sum of 2 continuous functions is continuous. Now, what I want to do, just for a bit of fun and to make it more relevant, is I'm going to chop off the 3 here and do 4. So we're going to use the open sets ideas to prove that the sum of 2 continuous functions is continuous. So let me just go up here. What I'll write the proof in. So what we want to do is the sum, I'm just rewriting what I have, the sum of 2 continuous functions is continuous. Okay, so proof. Okay, so let's talk, just work towards it. Let's just talk some ideas. Let me get the green, if I can get it on the fine one. Yeah, that's good. Okay, actually, let me just, I'm going to have to push that up so you can see that they're open. Yeah, you should be able to see that. Yeah. Okay, so if we were going to do a direct proof, what's going to happen is we're going to say, suppose, our first line is going to be something like, suppose U in Rn is an open set, or is an open set. What do we want down the bottom? Down the bottom, if we were going to prove this, then we would have something like, then F is open. Actually, we're probably more likely to say so or therefore. So, and then we would say therefore the sum of 2 continuous functions is continuous. Now, I haven't said at this point that the direct proof will work, but that's a good place to start. What you might put for the last line, or we might just put, this concludes the proof. You could even do that. So you might put, alternatively, you put, this concludes the proof for the last line. Okay, good. Now, in this area here, we have what I call a logical flow. So you start with what you know, you end up with where you want to go, and then in here you have a logical flow. Now, what are we going to use in this? We're going to use, well, if we call f and g the 2 functions, well, f is continuous. Therefore, the inverse of u, or the pre-image of u, we'd call it, under the function f, is will be continuous. We can take that as a given because that's what it means when we say the sum of two, up here we say the sum of two continuous functions. Well, f is continuous, that's what it means to be continuous in terms of this set, open set idea. And similarly for G. Okay, so I'm starting to get a bit of a feel for how this might work. So now what I think we should do is rub this out and actually draw draw a diagram, and then I think we'll be in a position to start the proof. So I'm going through this, trying to go through this slowly and logically. Obviously, if you're very, very good at this, or you've had a lot of, or probably more likely you've had a lot of experience, you could just write the proofs without any of all this explanation that I'm going through. So let's draw a little picture. So I'll start off with here, I'll draw, that'll be Rm, and over here we'll have Rn. Okay, so now let's label things a little bit. So here we have Rm, here we have Rn. Okay, so let's label a U. This will be our U. Okay, now we had these functions going across here, f and g. Okay. Okay, so with this U here, we know from what I said in the last one that we can map that to over here. This will be the inverse function. So this will actually be, I'll just put it here, f minus 1u. It's the pre-image of u. In other words, if we applied f to all these points here, then we would all of them would end up over here in u. Now we could do the same thing with G. Let's change the color. G we can also work out the pre-image. And so we could go to here's U, here's G negative 1. So this will be G negative 1U. Now, these are all open sets. So if you like, I should have actually drawn them like this probably, with dotted lines, which is the normal convention. So let me just fix all this up. It seems like I'm overdoing all the drawings and all that, but it is actually very useful. Now here's GU, sorry, G negative 1U, the pre-image of U. Okay, so we know that this set is open, or that's the assumption. Suppose this is an open set. What we're drawing on this is that this set here is open and this set here is open. Now, when we add the two together, we're going to have over here, let's do it in blue, and we'll call this F negative 1 plus G negative 1. Or maybe, in fact, it's better to go like this. I'm just going to add up the two. So it's F negative 1U plus G negative 1U. And in fact, what I'll do is, just to try and illustrate the point. So what I've done here is I've just added up an element from here and an element from here, and that element plus this element. So this might be, call this A and this is B. Then this point over here will be A plus B, whatever that turns out to be. Now I've drawn it in this way, half, neither open or closed, because in fact that's what we need to show. If we can show that this set here is open, then we will have achieved what we want. I suppose up here we could actually write it like this if we wanted. Under the rules of functions, that's what it means to add the two up. You could write it a new function like that, I suppose, or you could even write it like this. Okay, but however you write it, we need to show that that's open. Okay. So what I think I'll do now is start writing some stuff, and then we'll see where we get to. I've got one little trick left, I suppose. Suppose U is an open set in Rn. Since F is continuous, we have F negative 1U is open. Also, as G is continuous, we have G negative 1U is the preimage of U is open. Okay, so now I'm going to use a little trick which will break up the video into two. So I can just now write, it will suffice to show that the sum of two open sets is an open set. For then F negative 1U plus G negative 1U, which is equal to the inverse of F plus G, U will be an open set which will conclude the proof. Okay, so where have we got to? I've tried to give you a bit of an understanding of how you might logically try and work through this this proof or construct this proof, given that you don't know where you're heading. So we said, let's try for a direct proof. If it's a direct proof, then we know that we're going to have some line like this in, this first sentence in, and we're going to have some sentence like the last sentence or two in. We've drawn the diagram up here, which gave us a bit of insight. And where we've got to is that all we need to now show is that the sum of two open sets is an open set, and the thing's done. And this can be quite a good technique where you're a bit overwhelmed with a whole lot of things. What I've done is here, I've essentially simplified the problem. I had something that was difficult. We've worked through it, hopefully logically, and we've come to a very specific thing that we can focus 100% of our efforts on, which is to show that the sum of two open sets is an open set. So that's what I'm going to do in the next video, and that in doing that, that will then conclude the proof that we're doing in this video. If you've got any questions on anything I've done, please give me, please contact me by either commenting below any of my videos or dropping me an email to coronahelpmathematics@gmail.com, and look forward to seeing you for the next video where we'll wrap this up.